What if everything we think we know about reality is wrong? This question, once a mere philosophical musing, has become a scientific pursuit. Early in the 20th century, scientists embarked on a quest to find the elementary point particle that would confirm the physicality of our universe. But as they shattered electrons and other particles in enormous accelerators, they found themselves facing an astounding truth. The foundations of the physical world weren't physical at all. Instead, they found energy. The understanding of reality began to shift from a physical construct to an energetic one. The scientific community was left grappling with the idea that everything, at its most fundamental level, is not matter, but energy. A seismic shift in perception, akin to when Copernicus upended the geocentric model of the universe with his heliocentric theory. And just like that, the concept of a physical universe was turned on its head. Welcome to the quantum revolution, a world where particles aren't really particles. Let's take a step back to the early 20th century. Scientists held the belief that electrons, protons, and neutrons were tiny, solid structures, much like planets orbiting around a larger neutron within an atom. This perception, however, was far from the truth. The pursuit of understanding the universe led to discoveries that were nothing short of shocking. When scientists began smashing electrons and other particles in massive accelerators, they found that the foundations of the physical world weren't physical at all. Electrons, muons, tauons, quarks, and gluons revealed themselves to be zero-dimensional. They had no internal structure, no physical size, and were more like events than things. In other words, they were made up of energy, entirely illusory. Then came the concept of wave-particle duality. Electrons, these so-called negatively charged particles, were observed to behave as both a wave and a particle simultaneously. Their state depended on the experiment conducted. This duality baffled scientists and challenged our understanding of reality. Further complicating matters, electrons proved elusive. Pinning down a particle's velocity or its position is possible, but not both at the same time. Imagine a police officer clocking a car speeding at 150 miles per hour on the highway, but unable to locate it to give chase. That's the conundrum faced in the quantum world. Another peculiar trait of these energetic particles is their ability to be in more than one place simultaneously. This phenomenon, known as superposition, suggests that electrons and other non-particle particles can exist in hundreds of places at once, a feat only possible if everything is energy at the most fundamental levels. The more physicists unearth about the quantum realm, the more our conventional understanding of reality is turned on its head. Albert Einstein once expressed his desire to understand what an electron truly was. Today, we have an answer. It's energy. Einstein once wished to know what an electron really was. Now we know, it's energy. Reality is stranger than we think. It's energy, and energy is everything. Our understanding of reality has been fundamentally rocked by the revelations of quantum physics. The once unquestioned assumption that the universe is physically tangible has been upended. It's not about solid particles, but about energy, waves of energy to be precise. In the early 20th century, scientists embarked on a quest for the elementary point particle that all life is built upon. They hoped this would confirm that reality was not an illusion, but the universe had a curveball in store. As scientists began probing the depths of the atom, they found that the foundations of the physical world weren't physical at all. The particles they were smashing in giant accelerators were not solid, planet-like structures, but zero-dimensional events made up of energy. But the surprises didn't stop there. Electrons, those negatively charged particles, were discovered to be both a wave and a particle simultaneously. This wave-particle duality meant that electrons could appear in one form or the other, depending on the experiment at hand. Furthermore, these energetic particles could be in more than one place at the same time, a phenomenon referred to as superposition. These shocking revelations have profound implications on the scientific method itself. The emphasis on objectivity and the necessary separation of the scientist from the experiment seems to be cast into doubt. For how can one be an objective observer of a reality that is, at its core, energetic and constantly in flux, yet Despite a century of exploration and discovery in the realm of quantum physics, these mind-bending concepts have largely failed to permeate mainstream consciousness. We continue to live our lives within the confines of what we perceive as solid and tangible, largely oblivious to the energetic dance of quantum particles that underlies our reality. Reality, as we know it, has been transformed. It's not about solid particles, but about waves of energy. It's a quantum world, and we're just living in it.